Alright, we're moving into chapter 5, which covers the electrons in the atom. So we're going to kind of move away from the nucleus and knowing how many protons, how many neutrons, to actually kind of looking at what is happening and how these elements are interacting with each other. And it's really just all about what's going on with their electrons. So we're going to go ahead and get started. First, we're going to start by kind of going through some early models and what they kind of found about what was going on with the electrons. So the first one that I'm going to kind of discuss here is it was found by Rutherford. He kind of said that electrons would move around the nucleus like planets move around the sun. So he thought they just kind of rotated around. They really didn't know a lot about, the behavior of the atom, the electrons, and they really couldn't explain why when you heated a metal up, you were seeing different colors depending upon what element you were heating up. So they really didn't understand the properties of the electrons and knowing exactly what was going on. So then another guy came along, his name was Bohr. So he kind of proposed that an electron is found only in a specific circular path. So probably what you saw last year is you would see some diagrams where you would see something like that. So the dot in the middle is the nucleus, so we're not really concerned with that anymore. But he kind of thought the electrons were floating around in a certain path around the nucleus. So, and he thought the lowest level had the lowest energy. So this right here, I'm going to put like a 1, that would be your lowest energy level, and then you move out to a higher energy level. And he thought electrons could jump energy levels by gaining or losing energy, and they do that by absorbing heat. So you can either heat the metals up, you can stick them in the sun, but they kind of started to see that something was going on with the electrons when that happened. So they were finally starting to see some different behaviors about what was going on with it. So there are more levels than 2, but the higher energy levels are going to be furthest away from your nucleus. Now, he also discovered that it could only take on a certain amount of energy, and that's what the word quantum means. Just kind of remember that this means certain amount. So depending upon what level they were in, each level could only absorb a certain amount of energy. Okay, so the next couple slides kind of go through the development. So the Dalton model here, that was just kind of the original one. That was where it was started. I really didn't discuss that one. This Thomson model, they called that the plum pudding model, and it's kind of written there. It says plum pudding. They just thought at that point that everything was just kind of crammed together, that the nucleus and the electrons and the protons and neutrons were just all one mixture of things. So it wasn't really until Rutherford where they kind of thought that no, the nucleus is in the center with the protons and the neutrons, and something's going on with the electrons, and they're kind of floating on the outside. So then move to the next one I talk about, which was the Bohr model. So he's got the nucleus in the center, and he's got these electrons that can jump energy levels and by gaining energy. Now they do have to go back to their original state, and we're going to get more into that. But the current model, today's model, is more this one right here. So it's called the quantum mechanical model, where we really don't know exactly where the electrons are located. And we're going to kind of discuss that now. So I'm going to move to the next slide. So unlike the Bohr model, it doesn't involve the exact path that the electron takes around the nucleus. So really, with the current model, which is down here at the bottom, we're unable to determine the exact location of electrons. So this pink that's around the nucleus, the green and the purple, those are going to be the protons and the neutrons. That's your actual nucleus. The pink around it, that's just showing where the electrons should be. We call that the electron cloud. So we really only have a probability of finding it. We really don't know where those electrons are at any given moment, depending upon how much energy they're absorbing or how much energy they're giving off. So what we do know is there's actually a region of space where there is going to be a higher probability of finding an electron. So they're called energy levels, and energy levels are shown by a quantum number. So I'm going to try to draw a picture down here. and I will redraw this on a slide where I have more room. But we've got different energy levels, and we call them quantum numbers. So the one closest to the nucleus is 1, this is going to be 2, and this is going to be 3. So for each energy level that we have, there's going to be several orbitals, or what you can also call these orbitals are sublevels, is what you should think of them as. So within the levels, there are sublevels with shapes. So, and the shapes are S, P, D, and F. So right here is an S orbital, and I believe it's just called an S orbital because it's a spherical shape. And then the P orbital, you've got to take all three of those and put them together to make a P orbital. They're different orientations in space. So I can't draw very well, but this is what a P orbital would look like all together. I call it kind of like a flower. So that is what all three of those together, in a horrible drawing by Mrs. Jocelyn, but that's what it would look like. And then a D orbital, I'm not even going to attempt to draw that, but that all superimposed would be, all of this together would be what a D orbital looks like. And then an F, they don't have a picture of it, but these are very complex shaped ones. You don't really have to know the shape. I'm not going to expect you to know that. What I want you to understand is that an S orbital is made up of one orbital. It's just spherical shaped. So an S is just a sphere, and it can hold 2 electrons. And then a P orbital, with my fancy little drawing, it can actually hold 6 electrons. A D orbital, that one can hold 10 electrons, and an F orbital can hold 14 electrons. So when you say that these sublevels, if you look, you should see kind of a trend there. It's one orbital, but can hold 2 electrons. 3 orbitals can hold 6 electrons. 5 can hold 10, 7 can hold 14. So they're doubling. So it can hold 2 electrons in each one of its orbitals. So I'm going to draw a diagram and kind of show you what this would look like. You guys probably learned at one point last year in physical science how many electrons could be located in these rings. So you probably know on the lowest level it goes 2, and then the second level you kind of learned that there could be 8, and then 18, and then 32 if I get to that one. So kind of keep those numbers in mind. You did learn that in physical science. So in level 1, that's the quantum number 1, there's a sublevel, there's just an S orbital. And that's all that can be found in level 1. So think about this. An S orbital, we just said in the last slide, can hold 2 electrons. That's why that level only has 2. So this is level 1, this is level 2, 3, and 4. So then in level 2, you have, there's the level, there's an S orbital, and there's also a P orbital. So you put the 2 in front of it to say what level you're in. So it's level 2, sublevel S, level 2, sublevel P. You got to think of it like that to kind of keep this straight. So an S orbital, again, can hold 2 electrons. A P orbital can hold 6. So when you add that together, you get 8. That's why there can be a total of 8 electrons in that level. Then moving to level 3. There is a 3s orbital. There is a 3p orbital. There is also a 3d orbital. So if you think about this, add it up. S orbitals we said could have 2. P can have 6, that's 8. And then we said the d orbital could hold 10. That adds up to your 18 right there. So there can be 18 total electrons found in level 3. Then I'm going to go ahead and draw my 4th ring if I can fit it in here. So in level 4, you can actually have an S, you can have a P, you can have a D, and you can have an F. So if you add all those up, it's going to be 2 plus 6 is 8, plus your 10 is 18, and F can hold 14. Add it all up, there's 32 electrons in level 4. So I'm not really going to go any further than that. I just want to kind of stop and make sure you guys understand, have a basic understanding of where these electrons can be found. So you got to remember that the number in front, the 2s and the 3s, those are your, they call them principal energy levels. You can also see them as just quantum levels. Or I may just say energy level. So that's what level you're in. But then you've also got the S's, the P's, the D's, the F's. Those are your sublevels. Oops, sublevels. Can't draw that very well. Or orbitals. So there's your diagram. So then here you just kind of have a breakdown of what we've talked about. You've got your principal energy level. N equals, the quantum number is listed as N. So that's your main level. So you've got 1, 2, 3, and 4. These are your rings. So within those, I kind of went through, there's 1 sublevel, 2 sublevels. So this has an S. This is your S and your P, and it kind of says that off to the side, but this is your S, your P, and your D. And this has an S, a P, a D, and an F. So that kind of breaks it down and tells you what orbitals are found in those different levels. Then the last slide, this kind of breaks down in each level the maximum number of electrons, and I went through that when I talked about that diagram. So this just has an S. This has an S and a P to add up to that 8. This has an S, a P, and a D. And then this one, S, P, D, and F is where those electrons are coming from. So this is just a general idea of talking about the electron cloud and where those electrons can be found. We're going to get in the next video, we're going to get into how to write an electron configuration. Thanks.